These come from problem set 4, so this is question 2, and we have this pair of functions over here, f of x equals square root of x plus 2, and g of x equals x squared plus 7. And we'd like to find the composite functions f of g and g of f. Okay, so f of g, so what that means is we take f of x and we substitute g of x in for it. So f of x is the square root of x plus 2. Now, when I do these composite functions, wherever I see an x, I just put a parentheses for that outside function, okay, or the one that's on the left. And then you go in and you substitute into the parentheses the other function. So we're just going to put an x squared plus 7 in there in the parentheses. Now, in this case, we cannot take the x square root of x squared and 7 because we're adding those things. Because of this addition, we can't do that whole square root, so we're just done. Okay? There's nothing we can simplify. But g of f of x, on the other hand, we have x squared plus 7, and then the x squared, well, for x is the function f, so that's going to be square root of x plus 7. Now, we can multiply that out and simplify a bit, so I'm going to go ahead and do that. Remember, this is square root of x plus 7 times square root of x plus 7. That's the squared part, right? Okay. So if I take the square root of x times the square root of x, that's just going to give me x. Then I take the square root of x times the 7 here, and that's going to be 7 square root of x. Then I'm going to distribute through the 7. That's a 7 times square root of x. 7 times 7 we know is 49, and we still have this plus 7 hanging out here at the end. Okay, so now if I combine my like terms, there's only the 1x here. There's 14 of the square root of x's, and then 49 plus 9 would be 58, and that has that simplified. Okay, so that's question 2. The other I got was question 3. So given f of x equals square root of that and g of x equals that, find the following, g of f of x. So keep in mind, this is the same thing as g of f of x. It's just a different notation, okay? You can use whatever notation you want, but you need to recognize both, okay? So g of x is negative 1 over, boom, okay, 1 over the x. Now the inside function is just square root of 2 minus 8x. Now we want to find the domain. Okay, so the domain, we have two things to consider here. Okay, I'm just going to kind of use a little shortcut and use our final little function there, although this doesn't always work. What we need to do is look at when hold on, my brain seized up for a second. So we know for a fraction, the denominator cannot be equal to 0, right? So this denominator can't equal 0. Okay? But also we have a square root. Okay? That denominator is the square root. We know what's under it cannot be negative either. So our domain for this thing happens to be whenever the 2 minus 8x is strictly greater than 0. It can't include 0 and it can't be negative. So 2 has to be greater than 8x, which means we divide both sides by 8. Okay, divide those by 8. And if we reduce our little fraction there, we're going to wind up with 1/4 has to be greater than x. Now, I have to write that in interval notation. I usually start off with like a number line, and here's our 1/4. Okay, and I always use whatever number x is. So if you read this, 1/4 is greater than x. That means x is less than 1/4, right? So that's everything going this direction. If 1/4 is greater than what we're looking for, then what we're looking for is always to the left. So in interval notation, that would be negative infinity to 1/4, and we would use a parenthesis since we're not including the 1/4. It doesn't have that equal to part. Okay, that takes care of that one. Question 5. A raindrop hitting a lake makes a circular ripple. So I know I've got a little circle going on. Sometimes with these word problems or these long ones, I got to start drawing pictures or whatever. If the radius here, the radius is a function of time in minutes. That's supposed to be a f of, or an r of t. And it's given by this 30 times t square root of t plus 2. Find the area of the ripple. So area of a circle, remember, is pi r squared as a function of time. Okay, so the radius then is 30 times square root of t plus 2 squared. Now, anytime you square something that has a square root, you're just going to get whatever's underneath, right? So 30 squared is 900, and then square root of t plus 2 squared is going to be just t plus 2. So there is my area as a function of time. It only has the variable t in it, and that's what it means when it says a function of time. Then find the area when t equals 2. Okay? So if we evaluate the area at 2, we're going to have 900 pi times 2 plus 2. So let's see, 900 pi times 4. So that would be 3,600 pi. And it says the exact answer. So leave pi in there. Don't use like 3.14 or anything like that, because those are just approximations. Now, question number 8. Find a linear equation. So linear equation, always looks in slope-intercept form. It looks like this, but I tend to start off with point-slope form. But the first thing I need to do is find the slope. So the slope, remember, is y2 minus y1 over x2 minus x1, where your points are x1, y1, and x2, y2. Okay. So in this case, x1, and let's see, y2 is 4, y1 is 1, x2 is negative 1, x1 is negative 2. Okay, so that's 3, and that is negative 1 plus 2 would be 1. So my slope is 3. So I'm going to start off in point-slope form. So remember, there's a couple of different forms. That's slope-intercept. And then y minus y1 equals m times x minus x1. This is what we call point-slope. So I always use this one to start off with. So y minus, let's see, y1 was 1. The slope we found was 3. X minus x1, that was a negative 2. Then I'm just going to simplify a little bit, because I know this is a plus 2, so I'm going to distribute the 3. And be careful of your sign there. Remember, the negative and negative here gives me the plus. And then I'm going to go ahead and just get y by itself, so I'm going to add 1 to both sides, and y equals 3x plus 7. And there is my linear equation. All right, I hope this helps a little bit, and have a wonderful day.